Today we will talk about the Flash native architecture and its importance to digital workloads in the yottabyte era. Enterprises now need a quick and efficient method to analyze their data. However, traditional HDD-based systems have performance bottlenecks, especially when 30 or more hard drives are deployed, such as in the high-density storage node, where a single node performance cannot increase linearly. A common solution to this is to use RDMA over InfiniBand or RoCE to improve data processing. RDMA, in particular, simplifies the I/O stack for cross-network data communication. Here, data is written into the memory, such as DRAM, after which the CPU triggers the DMA instruction to send the memory data to the server over the RDMA-enabled network. Then on the server side, the RDMA-enabled network interface card, or NIC, sends data directly to the specified address in the memory. However, even with this improvement, persisting data to HDD media is possible only after the CPU finishes processing, such as eroder code computing from the memory. It is clear that HDD-based storage architecture cannot tap into the full potential of the flash memory medium. And so, we need a new storage architecture in the era of all-flash. That brings us to the flash native architecture. In the future, all-flash media will come in diversified forms, such as NVMe SSDs and NAND boards. A single node has a greater chance to fully release the performance of all-flash media. Let's see the core optimizations in the flash native architecture of Huawei OceanStor Pacific. First, the flash native architecture must still support RDMA technology, such as the RoCE network technology. Another excellent upgrade is the intelligent I/O scheduling. Typical multi-core processors like x86 and ARM are unable to give full play to release the performance of flash media. By contrast, OceanStor Pacific introduces CPU core grouping and I/O task classification, which assigns I/Os with different priorities. I/Os with higher priorities, for example, read and write requests from applications, are allocated to groups with more cores. The number of cores in a CPU core group is dynamically adjusted based on the system loads. OceanStor Pacific scale-out storage uses a fully symmetric architecture, whereby any node can complete the function logic used for the distributed cluster. Therefore, a single node inevitably introduces a large number of threads or cross-module context switches. The simplified I/O software stack enables storage nodes to maximize the performance of flash media. The final innovation is the TOE and DTOE software-hardware collaborative design. OceanStor Pacific uses the DTOE or Direct TCP offload engine to ensure that all client requests are processed by the smart NICs. This removes redundant operations like interrupts and switches between the user and kernel modes found in conventional paths, greatly simplifying the I/O process. In this climate, storage systems, due to its importance to the IT infrastructure, must be upgraded to meet demands of modern workloads and all-flash media. As intelligent SSDs and high-throughput network communication bus mature over the coming years, OceanStor Pacific will continue to innovate to meet the performance needs of new applications in the yottabyte era. That's all for today. We hope you found this video helpful. Thank you for watching, and I'll see you next time.